This is example 2-3. We're going to look at a piezometer. Right, so we have a tank over here where we have oil on the top and water at the bottom. And based on that, we want to find out what the height of the mercury, or that we know what the height of the mercury is in the tube. We want to know what the height of the water is down here. We're looking for H prime. All right, we can do that the same way that we have done other things, right? Basically, we just have to go through and see. We're going to go from one place of atmospheric pressure to another. So, for instance, we can start at the top of the oil here, right? So, if we want to find what the pressure would be all the way at the bottom, then we can start at the top of the oil, right? So we can say if we go down to here, up at the top, there'd be atmospheric pressure, so a gauge of 0. So if we go all the way through the oil, right, then we'd have the depth of oil times the gamma of oil. Then what is next, right? So then if we wanted to go all the way down, then we'd have to add the depth of water times the gamma of water. That gives us that all the way down on the one side. Now, if we can also go down from the other side, when we start at the top of the mercury, right, so that pressure would have to be the same once we get down there. So we start at the mercury. If we go down all the way here, right, so that would be H times gamma mercury. And then we have to go all the way down, which is our H prime, which is what we're looking for. H prime times gamma water, because we're back in water. And with that, we have all what we need, right? We can see we have H prime in here, everything else we know. So we can go ahead and solve this for H prime. So H prime is going to be all of this minus that divided by a gamma water. So we'd have D oil times gamma oil plus D water times gamma water. Then we have to get that one over there. So we'd have H times gamma Hg, kind of running out of space. And all of that we divide by gamma water. All right, very good. Now if we look through here, we can see that we have gammas everywhere. We're given rows instead of gammas, so but we have each term has a gamma in it, so we can just divide by G and get our rows, right? So we get D oil times rho oil plus D water times rho water minus H times rho mercury divided by rho water. Okay, if you plug those values in, the oil was 0.6 meters. The oil is given to us as 900 kilogram per cubic meters. The water has a depth of 0.8 meters times 1,000 kilograms per cubic meters. And then H is given to us as 8 centimeters times, we're running out of space here, kilograms per cubic meters. All of that divided by 1,000 kilograms per cubic meters. So that gives us 0.0936 meters, or 9.36 centimeters. Let's be careful here with our units. Yeah, units comes out to be meters, right? Because all of the densities cancel out. We're left with meters. And 9.36 centimeters, based on all the other ones here, seems to be a reasonable value. All right, so now we figured out what that H prime would have to be based on the different densities and the different depths.